In a rolling mill, the roll absorbs heat when it bites the rolled stock, which is generally at a higher temperature. The heating of the rolls decreases their hardness, which in turn shortens their lifespan. Further rise in the temperature of the rolls leads to the growth of fire cracks. This severely hampers the surface quality of the finished product. In the conventional way of roll cooling, water is poured from the top of the roll, which does not exactly cool the rolls but causes many problems like development of fire cracks, increased downtime due to frequent change of roll pass, roll breakage due to deepening of surface cracks, lower roll pass life, reduction in hardness of rolls. Roll cooling is an important parameter to maintain and increase the life of roll pass and of rolls. In a more efficient practice, the coolant or water should be sprayed at the discharge end of pass when the material leaves the periphery of the roll. It is recommended to install a loop-type spray bar having holes to strategically mount spray nozzles for effective and instant cooling of rolls. Good roll cooling means rolls to be maintained at ambient temperature. Also, uniform distribution of temperature throughout the barrel length of the roll should be ensured. A good roll cooling involves the following: optimizing water requirement and supplying only that much water which is required. Supply of water such that 1/3 of the roll surface is water cooled. Also, controlled flow of water to be ensured through a common header and nozzles. Similarly, for 3 high mill stands, most commonly 2 cooling pipes per roll and segment pipe at critical places are used. In this way, uniform cooling of rolls is made possible. This increases the pass life and in turn also the roll life. Efficient roll cooling also decreases the roll consumption per ton of steel production. Roll cooling should be done in a controlled manner with proper monitoring. The amount of cooling water required depends on parameters such as peak load, number of bearings, journal diameter, RPM of rolls, heat lost by material per pass, heat absorbed by water per pass. Also, capacity of the mill in TPH, typically the total quantity of water requirement in cubic meter per hour for a typical TMT bill consisting of roughing mill, intermediate and 4 finishing stands works out to be 250 cubic meter per hour without a cooling tower and 170 cubic meter per hour with a cooling tower installed.